Hello and welcome to our Geomagic Control X and Artec Space Spider collaboration. The purpose of this demo is to show a prospect how to quickly and easily validate a part or manufacturing process by comparing 3D scan data to a reference CAD model. An overview of what this demo consists of: we will import data. We will do an initial alignment which roughly aligns the measured data to the reference data. Then we will do a more refined alignment using datums. Once aligned, we can now use our compare tools: 3D compare, comparison points, and 2D compare, which shows profile deviation between the measured and the CAD data with a set deviation. This is a great tool for first article inspection to assure that the manufacturing process is correct. Then we will get into dimensioning the part and also utilizing our GD&T functionality. Once the critical dimensions are made, we will generate a report. First, we will open a new Control X workspace. A user profile will prompt. Control X has user profiles to set up the user interface based on the type of user or the intended workflow. These profiles are able to be edited and can be tailored to the customer's specific needs. Expert is the complete set of tools. Basic is designed for simple inspection workflows. Operator is designed for an operator to execute an established inspection program. We will choose Expert. Let's import the Artec Start CX project file. Once open, you will see that the measured data is not aligned to the CAD data. To get a rough alignment, let's use the initial alignment tool and click the check mark. The initial alignment tool recognizes similar features on both the reference and measured data to perform a quick best fit alignment. Once the data has been pre-aligned, you can refine the alignment using one of Control X's more advanced alignments, such as the best fit condition or a datum alignment. Now that we are roughly aligned, let's use the datum alignment tool, which aligns the measured data to the reference data by matching critical geometric features defined as datums. Let's use the main cylinder for datum A while holding the shift key to select both portions of the cylinder. Use one of the two mating planes for datum B and use the bottom mating plane for datum C, and click the check mark to accept. Now that we have our data aligned to datums, let's use the 3D compare tool to analyze the deviation between the reference and measured data by projecting all paired points or polygons onto the reference data. The deviation is displayed with a color map, often referred to as a heat map, which helps visualize negative and positive deviation across the entire part. Open the 3D compare tool in the Compare tab. Under Projection Direction, we want to click Along Normal and click Next Stage. Under Display Options, check the color map and show contour lines. We want to change the specific value tolerance from plus or minus 0.1 to plus or minus 0.25. Next, turn on the local averaging tagging by checking the boxes next to the over tolerance and under tolerance count. Click the checkbox to accept, and for reporting purpose, orient the part in a way that best depicts critical information. Highlight 3D Compare in the Model Manager. In the Result Navigator, hit the Reassign Viewpoint, and this view will now be generated in the final report. Now let's use the comparison point tool. This will let us highlight critical deviation zones between the reference and measured data at specific points. Comparison points are established on the reference data, which allows them to be repeated. Open the Comparison Point tool in the Compare tab. Under Method, select Pick Points. Under Color Bar Options, change specific tolerance from plus or minus 0.1 to plus or minus 0.25. Zoom in to a critical position on the part that is showing deviation and click some of the critical high and low positions. Check Accept. Like 3D Compare, orient the part in a way that best depicts critical information. Highlight CMP1 in the Model Manager. In the Result Navigator, hit Reassign Viewpoint, and this will be generated in the final report. Now let's use the 2D Compare tool to analyze the deviation between the reference CAD and the measured data on a 2D section profile. The 2D Compare provides a similar visual to the 3D Compare tool. Let's open up the 2D Compare tool in the Compare tab. Under Set Section Plane, set Offset and choose Plane Z as the base plane. Keep Offset Distance at 0 and click Next Stage. In Next Stage, change the Use Specific Tolerance from plus or minus 0.1 to plus or minus 0.25. Also, turn on Local Average Tagging by checking the boxes next to Over Tolerance and Under Tolerance Count. Click the check box to accept, and note if there are no over or under tags, the part does not deviate from the reference in that direction. Now it is time for the geometric dimensioning tools to analyze dimensions on critical features. Click on the Dimensions ribbon, highlight 3D GD&T, then click Add Group. Click the Smart Dimensions tool, and note that the Smart Dimensions tool is a single tool that combines the 4 standard dimension types into a single tool. Each dimension is automatically determined by the combination of selected target entities. Measure the overall length of the part. Click on the first CAD plane, click on the second CAD plane for a linear dimension, and change the tolerance from plus or minus 0.1 to plus or minus 0.25. Measure the angular dimension. Click on the first CAD plane, click on the bottom CAD plane for an angular dimension, and keep the tolerance at 0.1. Measure the radial dimension. Click on the main CAD cylinder for a radial dimension, and change the tolerance to plus or minus 0.25. The Smart Dimension tool allows for creation of multiple dimensions of varying type without exiting the tool or manually accepting each dimension. To have a more detailed annotation shown for the dimensions, right mouse button on the annotation, click on the preset, click on Detailed. Annotations can be customized by right-clicking on an annotation. You can choose from a list of preset styles, or you can choose Edit Annotation Style and customize the annotation. You have the option to do this for one tag at a time, for a group of annotations, or for a specific type of annotation. For more individual dimensions, left mouse button on specific dimensions. Use the same as Smart Selection. For reporting purposes, orient the part in a way that best depicts critical information. Highlight 3D GD&T Group 1 in the Model Manager. In the Result Navigator, hit Reassign Viewpoint. Now let's go through a few GD&T callouts to analyze critical features which will need to interact with other components in a specific way. Open the Dimensions tab, highlight 3D GD&T, click Add Group. There should be a Group 2 under the 3D GD&T in the Model Manager. Before setting up a concentricity measurement, a datum must be first established, which the feature will be measured against. Click on Datum in the Geometric Tolerancing tab and select the CAD cylinder to establish datum A. Click the check to accept. Click on Concentricity. Select the CAD cylinder closest to the mating plane. Change the tolerance to plus or minus 0.25. Select datum A in the drop-down and click the check to accept. Click on Flatness in the Geometric Tolerancing tab. Select the mating CAD plane and change the tolerance to plus or minus 0.25. Check Show Fitting Deviation and click the check mark to accept. Note, flatness will be measured against the planar feature you select, which means you don't have to establish a datum separately. And for reporting purposes, orient the part in a way that best depicts critical information. Highlight 3D GD&T Group 2 in the Model Manager, and in the Result Navigator, hit Reassign Viewpoint. We can move on to the cross-section tool to create 2D sections from the reference and measured data. The cross-section tool generates 2D section drawings similar to 2D drawings in most CAD packages. In the 2D section view, you can inspect features using the 2D GD&T tools. Open the Dimension tab, highlight 2D GD&T, click Add Section, select the bottom CAD plane, enter 2 mil offset distance, use reverse direction, and click the check to accept. Now open up the Smart Dimension. Select 2 CAD lines for a linear dimension. Change the tolerance to plus or minus 0.25. Now click on the 2 CAD circles for a linear dimension between the 2 circles. Tolerance plus or minus 0.25 and click the check to accept. Now that the inspection program has been established, it's time to generate a report. By default, everything you inspect will be included in the list of selected entities. You can add or remove inspection entities for the report by selecting the item and clicking the left and right arrows to move it in or out of the list. You can also prioritize entities using the up and down arrows in the dialog box. Open Generate Report, highlight Initial Alignment, and use the left arrow to remove from selected entities. Check the 3D PDF page and add Artec Demo Kit in the title bar. Click Generate. This concludes our Geomagic Control X demonstration. We at Geomagic like to offer benchmarks for the customer to allow them to get excited about all Control X offers. Make sure to collect usable data with your hardware, and please utilize our ODM service to help provide assurance that the customer is buying the right solution. Please reach out to us at Geomagic if you have any questions. Thank you.